As it approaches the Earth, it starts to accelerate as it starts to feel the Earth's gravitational pull, and at that point, everything changes.
Now in gravity's grip, the space rock picks up speed. If the meteor survives the impact, the camera data will allow scientists to mount a search to try and find it. But surviving this journey is easier said than done.
So as the rock comes into the Earth's atmosphere, it's moving something like tens of times the speed of sound. So it's moving 10 or 20 times the speed of a rifle bullet, very, very fast.
Now, 60 miles from Earth and just 3 minutes to impact, the meteor slams into the atmosphere like a ton of bricks. The white-hot rock burns at over 2,000 degrees.
At that speed, the air molecules start to heat the surface. And as the surface gets hotter and hotter, material begins to come off of it. And that's actually what produces the light that we see in the sky as a meteor.
The meteor is now a fireball, and it tears through the atmosphere on a collision course with Earth.
As the rock gets deeper in the atmosphere, it basically hits a brick wall. It hits the thicker part of the atmosphere and shatters. So whatever's left of the rock gets crushed.
During the mid part of the flight where you see all the bright flashes, there are lots of pieces being released. It's fragmenting, there's lots of light. Some of those pieces are going to fall down, but right at the end here you can see there's sort of 5 major fragments that are left.
The smaller fireballs begin to slow down to speeds of 6,000 to 9,000 miles per hour. They also start to cool, and when they finally extinguish, they become invisible to the cameras.
That process is called dark flight because there's no luminous phenomena associated with that stage in the meteorite's flight. And of course that ultimately ends in rocks on the ground.
The scientists will try to recover one of these meteorites. And the combination of this video, these infrasound readings, and this radar data could help them trace its journey back to its origins in space.
What's really cool about that is you can take the rock that you have in your hand and you can go backwards. You can take it through the fall event back into the orbit that it had before it hit the Earth and make some reasonable estimate about where it came from in the asteroid belt.